Today I'll be demonstrating to you how to conduct a fuel system pressure test. So you may be wondering, why do we want to conduct a fuel system pressure test? So on this motor vehicle that we have here, we have a no start condition. The students and I have already checked the ignition system. We had good spark coming from our ignition coils, right? We have checked injector pulse, right? We have scanned the vehicle for codes, right? There is no trouble codes. The computer was controlling the injectors, right? So we have suspected that probably the pump, the fuel pump, is not working. So what we're going to do now, we're going to confirm if the pump is actually delivering sufficient fuel pressure to our fuel rail here, right? So to do this, we would need a fuel system pressure gauge, right? So what I've done here, I've gone ahead, right? I'm connected up our fuel system pressure gauge here, right, to the fuel system here. So if you should come in a little bit further, right? We have keyed in our gauge here to the fuel line coming from our fuel tank. So but before we did that, right, we had to depressurize the fuel system, right? The reason why we need to depressurize the fuel system before connecting our gauge to the fuel line, because the fuel lines would have had fuel inside there under pressure. This is a high pressure system. We're talking about pressure anywhere from between, let's say, 35 to 50, 60 psi there, right? And it is very dangerous pressure, right? So if we should open that line without depressurizing the system, the fuel could spray out in our eyes, right? So we need to have our fire extinguisher nearby whenever we're working on the fuel system. We also need to have our eye protection. My eye protection is not with me right now, right? Also, we need shock rock, just in case you have any fuel spills, so we can clean up the fuel spills. Right? So this is how we had depressurized the system, right, earlier. So what we did, right, we locate the fuel pump relay, right, or you could have located the fuel pump fuse, right, or you could have just gone ahead, gone back to the tank and disconnect the fuel pump from there, right? But it's easier, much easier here. So if you should look here, so in the underhood fuse box here, we located the fuel pump relay here, right? So we just remove the cover, right? And we remove the fuel pump relay, and then we ask a student to start the motor vehicle, right? So let me just show you how the engine would sound with the thing depressurized, when it's been depressurized. Right? So we would do this process several times, right, until the engine runs, right, and shuts off by itself, right? So now it's now time for us to check the fuel pressure, right? So what I will do now, will ask my student again, Simit, to prime the fuel pump, right? So priming the fuel pump, we're going to he's going to turn the ignition key on about several times, and we're going to check the pressure, right, on the gauge. So if you look at the gauge here, prime, do that several times for me. Alright, again. Alright, so as you can see, as he's priming the system, turning the ignition on and off, we should build pressure. Alright, so we know at this is what, about 15 psi. Let us remove this here. I'm going to ask him to try and start the motor vehicle now. Try and start the motor vehicle, see it? Alright. So as you can see here now, with the motor vehicle started, right, we are having a fuel pressure, right, of about 55 psi, as you can see on the gauge here, right. So this is sufficient pressure, right, for our fuel system here. So anything below, let's say about 35 psi would be cause for concern, right. So what we have here, we have sufficient fuel pressure, right? So that pump, the pump in the back of that car there, right, is a healthy pump, is able to deliver the correct amount of fuel pressure first. Right, so I'm going to ask them to shut the vehicle off now. Right, so with the vehicle off, if the pump, so we're going to do another check on the pump now, right? So with the vehicle off, and if the pump, if the check valve inside the pump, the pump has a small valve in there that's called a check valve. And what that check valve does, it prevents whatever fuel that's in the line from running back into the tank while the vehicle is off. So if you look at the gauge, come over here and take a look at the gauge, right? So if our needle is falling, right, rapidly, that would be an indicator that the check valve inside the pump, the check valve inside the pump is not working. So it has now been several minutes has passed, right, and we're still maintaining a pressure with the engine off, right, in the fuel lines of about 50 psi here, right. So what that can confirm for us is that the check valve, right, inside our fuel pump is indeed fine, right, and as you can see the running pressure, right, that we had about 55 psi there, which is within specifications also for this type of motor vehicle. Alright, so that is how you conduct a fuel system pressure test on a motor vehicle. Again, let me just do a little recap here. Reasons why you want to do a fuel system pressure test. So let's say, for example, again, your vehicle is not starting, the engine is not starting, you have checked spark, right, from your ignition coils and so on, and that is good. You have checked the injectors to see if the computer is pulsing the injectors on and off, turning the injectors on and off, right, and that is also good. You have checked the compression, right, with your compression gauge, and that was also good. So it would be now a good time to check your fuel system pressure to see if the fuel pump itself is delivering sufficient pressure to the fuel rail, right. So now it is now time to remove our gauge from the system. But as you can see, right, we are at 50 psi here on the gauge. So if we should now go ahead and release the clamps here, or remove our gauge as it is now, what would happen? We would have fuel spraying all over the place at us, right? So again, just as before connecting the gauge, we had to depressurize the system, right? So now to remove the gauge, again, we need to depressurize the system once more. So we're going to remove the fuel pump relay once more. Again, that's our fuel pump relay. This is how we located it. Right? So we could have also used the fuel pump fuse, but the relay is easily accessible here. So we're just going to pull the relay. We're going to ask the student inside the motor vehicle to turn the engine on. So we're going to allow it to run. As you can see, the needle is now falling because we are using up all of the residual fuel pressure that's inside the fuel rail here. So we want to do this until our gauge is reading near zero. Alright, so he's going to do that one more time. Again. Alright, so our system would have now been depressurized, so it would be now time for us to disconnect the gauge from the system. Students, so we have depressurized the system, so now we are disconnecting the fuel pressure gauge from the fuel line. So now we're going to disconnect that. So we're going to connect up our hose right up onto the fuel rail there. So for that we need a clamp. So we're going to clamp that hose to the fuel line there. This fuel system here, this fuel line here, we have modified it for training purposes. Right? So this motor vehicle here is not going on the road, so if it was a motor vehicle that was going on the road, we wouldn't be doing anything as such. So we push it on like that, right? And we use a little clamp here, right, to clamp it on like that. And that is how you perform a fuel system pressure test, right, on a fuel system, and a high pressure fuel system. And we're not talking about high pressure, we're not talking about anything like GDI, we're talking about a multi-port fuel injection system, because on a GDI system, the fuel pressure would have been much higher than this. We're talking about fuel pressure in the range, ranging like about 100 psi upwards, right? So compared to GDI system, this is a low pressure system, right? So that is how you conduct a fuel system